So this is 4-2, comparing and ordering rational numbers. Raise your hand if you think you know what a rational number is, or the definition of a rational number. Anyone? Rational. There's a word in it. Josh? This Josh? No? Kendall?
Like ratios?
Like ratios? And what are ratios? What do they look like, Logan? What do ratios look like when we write them? Rachel? Fractions. Good. So rational numbers are any number that can be written as a ratio or fraction. A rational number is any number that can be written as a ratio or fraction. These include common fractions, like 1/2, 2/3, terminating and repeating decimals. Those are rational numbers. Remember on your homework last night you had to go back and forth between fractions and decimals and fractions, so those are all rational. Percents are rational because percent means over 100, right? And integers are rational. So all the integers up on the number line, all those are rational. You could write those as a fraction. You could write them all over 1. Can anyone think of a number that's irrational? We'll do more of irrational numbers in 8th grade, but just curious. Anyone know of an irrational number? It's a very popular number. Pi. Good. Pi is irrational. It does not repeat. It does not terminate. Many crazy people have locked themselves in attics and basements for decades trying to figure out the last number of pi. No one's found it. It's irrational. Question, Logan?
There was this one dude, I was just, I don't know how to put it, but he can do any math problem in his head.
And he's probably looking for that last digit of pi.
He, like, the numbers that everyone knows, he can repeat them.
Yeah, a lot of people memorize a bunch of digits of pi. I don't memorize them because they're in my calculator.
3.14.
Good. 3.14 is about what I have to. All right. Now this part's a little bit of review, so if you don't need to write it down, that's fine with me, but I'm going to talk about it. Shh. Common denominators, this is the review part. So again, write it down if you need it. But recall that common denominators are a common multiple of the denominators of 2 or more fractions. So that's the number on the bottom of the fraction, right? So common denominators, we're going to be using those when we compare and order rational numbers. We have to put them in the same form, which means they'll have the same common denominator. The other thing that's review for you guys is the lowest common denominator, which remember was the LCD, and that's the least common multiple of the denominators. Okay, so you can use that to compare fractions and use them on a number line. In the warm-up, you had to compare them on a number line, and you actually found the LCD, or some of you did, for the one that was 2/3. You found out that it was 12. Okay, so these two review. If you need to write down any words there, go ahead. I'm not going to test you on defining it, but you do need to know what they are. So if it says in your homework or on the test, find the LCD, you need to know what that means, right? But I'm not going to ask you to write out the definition. Okay? Any questions on those two things? Do you remember those from elementary?
Yeah.
Okay. Whenever you were adding fractions with unlike denominators, this is what you did. I know you loved that whole chapter in elementary school, right? Adding fractions with unlike denominators.
They were fun.
What was your favorite? I know. Okay, so here's an example of what you would have to do. Okay, so you saw this on the pretest. It's greater than, less than, or equal to. And they'll give you two mixed fractions, something like that. And you have to figure out which one is bigger, or are they equal. This one's not too bad because you notice that they have the same common denominator of 6. Raise your hand if you think the left side is bigger. The left side. The one with the -1 and 5, 6. Raise your hand if you think the right side is bigger, -1 and 1, 6. Okay, so here's the answer. Okay, so those that said the right side was bigger are correct because we're looking at negative numbers, so we have to think opposite, right? So the -5, 6 will be farther to the left on the number line. The -1 and 1, 6 will be farther to the right, closer to 0. It means it's bigger. Okay. Now you could also use a number line, and I'll show you in case you have to do this on a test. You don't have to write it, but you can if you want. But you could just look at your numbers. So I have the -1, 0 somewhere out here, right? And then I can see that this -1, 6 is bigger than -5, 6. Okay? So just understand how to set it up and how to read a number line. Any questions on that? Okay, so raise your hand if you think this is the easy stuff right here. This is good. We can do this? Okay. Raise your hand if you're like, I kind of remember this. Kinda. Okay. All right. Okay, can I turn the page? Yeah. This will be online today too if you want to write more of it down. And all these definitions are in your book as well. Okay. So let's do another example. So again, we're going to look at less than, greater than, or equal to. And here I have two fractions, but I don't have the same denominator. Raise your hand if you think the left side is bigger. Raise your hand if you think the right side will be bigger. Raise your hand if you don't know. You don't know yet, because you have to get the common denominator, don't you? So, the lowest common denominator, okay? That means on the bottom, the denominator. What is the smallest number that both of those numbers go into evenly? Zach. What?
36.
No, it's the number they go into. Josh L? 36. And how did you get 36? Okay, so let's do that, you guys. Let's times this one by 3, and that will be 36, right?
Couldn't you simplify it?
Nope. And what about this side? What do I have to multiply it by, Josh?
2.
Good. Both Joshes are good. So they both make 36. Now, remember, whatever I multiply on the bottom, whatever number, I have to multiply on the top. So that means this one will now be 7 times 3 is?
21.
Good. And 8 times 2 is? 16. Now, which one is bigger?
21 over.
This one is bigger, right?
21.
Aha. Okay. So here it is worked out again. 21 over 36. 16 over 36. And so, since 21 is bigger, then that means the 7/12 is bigger. You don't have to rewrite all this. We did it up here. Okay? All right. Does that make sense? Find the common denominator. Now, some of you are like, I don't know how to get 36. That was crazy fast, right? Josh is just amazing with common denominators. Right, Josh? Yeah. Now, some of you are like, it takes me a while. That's okay. You can always multiply the two together. You'll get a big number, but you can do that, okay, if you're unsure.
You're good at examining.
All right, so I want you guys to try this one right here. Try 5, 6, and 7 ninths. Tell me which one's bigger or if they're equal.
Would you guys ever say numbers at times?
You have to get the lowest common denominator, yeah. Zach asked before, can you simplify? You can't because there's a prime number there, that's 7. Can't simplify a prime number. 7?
Well, you could do it in decimals.
Yeah, but we're not doing decimals. We're doing fractions. Okay, raise your hand if you have the answer. Okay, now raise your hand if you think the left side is bigger. Raise your hand if you think the right side is bigger. All right, here's the answer. Okay, what is the lowest common denominator of 6 and 9? Corey? 18. Good. So that means we multiply by 3. 6 and 9 is 18, so we multiply by 3 here to get to 18. So that's 15 over 18. Multiply by 2, 14 over 18. Good job. Okay, try this one now. 1/5 and 7/50. This one's a little bit easier. Okay? Times 2. This is times 3, and this is times 2. It's a number they both go into, right? They both go into that. There is.
Would you have to take a random guess?
No. Raise your hand when you think you know this one. This one's a little bit easier. You probably don't need to write anything down. You just know it. 10 more seconds. We'll see if everyone can get it. Okay, now raise your hand if you think the left side is bigger. Raise your hand if you vote for the right side. Okay, here's the answer. Nobody voted for the right side. That's a good sign. So 5 goes into 50 already, right? So it's just times 10. So now we have 10 over 50 is greater than 7 over 50. Raise your hand if you just did this one like in your head. You didn't need to write it down. Yeah. Because we're good with 10s, right? We're good with 5s and 10s. You wrote it down? All right, try this one now. We have negative numbers. I want to see if you can still figure this out with negatives.
Oh, snap.
Uh-oh. This one might be an example of it's just easier to multiply the denominators, right? Raise your hand when you think you have it. Okay, before we vote, I want you to talk in your group for about 30 seconds and compare what you got. Five more seconds. Okay, stop. Raise your hand if you think the left side is the bigger number. Raise your hand if you vote for the right side. Ooh, it's about half and half. You ready for the answer?
Yes.
Dun, dun, dun. I'm going to show you how. Here's how you do this one, guys. The common denominator, I'm going to say, is 160, right? Okay, it's 80. You can do 80, but let's just, for the easy factor here, multiply the 2. Okay? So if I multiply this one times 10, I get negative 90 over 160. If you did half of that, then you just cut that in half, negative 45, right? This one is going to be times 16, and that would be negative 112. And we're looking at negatives, and remember, the smaller negative is actually the bigger number. Smaller negative is closer to 0, right? So raise your hand if you got that right. Wow. Good job. Closer to 0, so it's bigger. All right. No, 16 and 10. You have to look at the denominator. Okay, the other thing you guys are going to have to do on this quiz and this test and your homework is you have to order rational numbers by place value. You have to be able to order rational numbers by place value. Okay? That means you're going to have to put numbers in order, and you're going to have to look at those decimals. That's why in the warm-up I had you rounding numbers. Okay, so here's an example. You'll be given a number set. These little squiggly brackets, whenever you see those in math, that means number set. Okay, so we have 3.44 pi, which is 3.14, right? But it keeps going. We also have 3.14 ending, and we have 3.4 repeating. So we need to order them, and you always go from lowest to highest. So which one, raise your hand, do you think is the lowest number here? The smallest number. Brock. 3.14 ending, right? The smallest, everyone agree? Yeah. Okay, and then what's the next one? Raise your hand. After 3.14 ending, this is not really that difficult, but Rebecca, what do you say? Pi, good. So that one has some digits. And then after that, which one? Which one? Someone different. Josh.
3.44.
Good, 3.44, and then repeating. Okay, so here you go. 3.14, pi, 3.44, and 3.4 repeating. Because this 4 will just keep going, right? Yeah. Okay. I put over here on the side what pi is, just so you guys know. It goes 3.14159, and then a bunch of other numbers after that. Okay, on your quiz, you'll have to do this. Sometimes with decimals, sometimes with fractions. All right. So I want you guys to try this one. This one has a percentage in it. It has a decimal. It has fractions. Do you remember how to write percentages as fractions?
Yes. Move your percentage.
Okay, so go from least to greatest. Remember, to order the fractions, you're probably going to need that lowest common denominator as well. Unless you just know it.
I know.
Some people do. They're really good with that. Some people need to get the common denominator. Raise your hand if you think you have this. You have them in order. You know this. About 30 more seconds. We'll see. Okay, you ready? Ready? Here we go. Okay, everybody, what number do you think comes first? Just say it.
1/5.
Okay, so that's correct. 1/5. Because if you multiply, if this is over 100, you could multiply everything to make it over 100, right? Okay, so you'd multiply by 20, so that'd be 25ths. Okay, or 20 hundredths. And then what about the next number? Say it out loud.
21.
Ah, 0.21. Good, because that's 21 over 100. Okay, what about the next one?
23%.
Good, because that's 23 over 100. And then the last one is 1/4. Now raise your hand if you got all those right. Wow. I'm impressed. Yes.
I just changed them off percent. 1/5 is 28.
You could do that as well. Did you hear what Rebecca said? She just put them in percentages. Anyone else do that? Good. 20%, 25%, perfect. 21%, nice job. All right. So on page 274 in your book, 274. Go there. We are going to do 1 through 4. 1 through 4. Give you guys about 5 or 6 minutes and we'll go over it and then we'll move on to the next practice.